Okay, so we had just solved for what our x value is, and now it's time to solve for our y. I'm going to plug into my second equation. All right, since they're all positive, 5 times 4 plus 6y equals 14. 5 times 4 is 20, plus 6y equals 14. I'm going to subtract 20 from both sides. 6y equals negative 6. Divide both sides by 6 and get y equals negative 1. So my solution is 4, negative 1. If I do the algebraic check, I'll use my top equation just because I use my bottom equation to solve for my y. So let's go 3 times 4 minus 4 times negative 1, right? I'm using these values, equals 14. 3 times 4 is 12. Negative 4 times negative 1 is positive 4, equals 16, not 14. Change that. 16. 16. Yes, 16 equals 16. Check. All right, let's go. We got 2 more word problems here. The first one is talking about a concession stand at the USC lacrosse game. So Mr. Jones bought 9 slices of pizza and 5 soft pretzels for $33.25. Then Mrs. Smith bought 4 slices of pizza and 6 soft pretzels for $19.50. What is the cost of a single slice of pizza and 1 soft pretzel? Well, I underline these in different colors because we are going to make a system, the blue being Mr. Jones' information and the green being Mrs. Smith's information. So if I take a look, Mr. Jones, he bought 9 slices of pizza and 5 soft pretzels, and he had a total of $33.25. All right, well then Mrs. Smith went and bought 4 slices of pizza and 6 soft pretzels for $19.50. All right. Well, I'm hoping you guys can see that you want to use elimination for this system because they're both set up into standard form. All right, well, first thing we do in elimination is to see if we can add these terms and something eliminates. Well, 9x and 4x is 13x, so that doesn't work. 5y and 6y, I get you 11y, doesn't work. So we now need to multiply one or both of these equations by a number in order to get opposite coefficients. So I'm going to work with my x's. I know that a common multiple between 9 and 4 is 36. All right, so I need to get one to be 36x, the other one to be negative 36x. Well, I can multiply this top equation by 4 and the bottom equation by negative 9. All right, so go ahead and do that and check your answer with mine. Hit pause and then come back and check your system. Okay, so hopefully you have this exact same system. We're going to add them. 36x plus negative 36x eliminates. 20y plus negative 54y is negative 34y. 133 plus negative 175.5 is negative 42.5. All right, so our x is eliminated. We now need to solve for y. We're going to divide both sides by negative 34. Y equals 1.25. Okay, well that does make sense. Since we're talking about the cost of a single slice of pizza or the cost of 1 soft pretzel, having a decimal does make sense. By the way, defining what our x and our y are, x and y. If Mr. Jones bought 9 slices of pizza, it's not the number of slices, it's the price per slice of pizza. And y is going to be the price per soft pretzel. probably should have done that before. But so we have y equals 1.25. Okay, well, let's go and find out what our x is. All right, so I'm going to substitute into the first equation. 9x plus 5 times 1.25 equals 33.25. Start simplifying, multiplying anything I can. Subtract 6.25 from both sides. 9x equals 27. Divide both sides by 9. X equals 3. So my solution is really 3, 1.25. But what does it mean? Well, each slice of pizza costs $3, and each soft pretzel costs $1.25. Word problem has a word answer. And the last problem, the cost to produce an authentic USC t-shirt is $350 with an additional $161.50 in labor and equipment costs. Then the t-shirt gets sold for $8.25 each. What is the break-even point? Ooh, we've seen that before. That's dealing with cost and income. So your cost equation is how much does it cost to produce these shirts? Well, it's $350 each shirt with that additional $161.50. So our equation is y equals 350x plus 161.50. X is going to be the number of shirts, and y is going to be the cost. Now, I need another equation, but then it's the income. Remember, break-even point is about cost and income. So your income, those shirts are going to get sold for $8.25. So y equals 8.25x. Well, in this case, x is, once again, the number of shirts, but your y value is really your income. And it can be both. Sometimes we just call it money. All right, so if I see this system, I hopefully will hear all of you saying, use substitution to solve, because they're both set up y equals. When they're both set up y equals, we essentially just set them equal to one another, which is really substituting this expression in for this y. All right, so let's do it. 3x plus $161.50 equals 8.25x. Let's get my x's together by subtracting 350x from both sides. I'm left with $161.50 equals 4.75x. Almost there. I need to divide both sides by 4.75. And x equals 34. Okay, great. Well, if x equals 34, okay, remember, x is the number of shirts, so something with 34 shirts. Okay. Let's find our y. I'm going to use the second equation because I think it's going to be a whole lot easier. Y equals 8.25 times 34. Y equals, if you do that math, $280.50. So our break-even point is right here. But what does that mean? Well, it means that the company needs to produce and sell 34 shirts in order to break even. They need to pay $280.50 to produce the shirts and sell the shirts for a total of $280.50. All right, their profit at the break-even point is I can hear you all say it, $0. So that's what that point means. Hopefully this worksheet helps you decide when you should use substitution, when you have a variable isolated, or when you should use elimination, meaning you have your two equations in standard form. All right, thanks for watching.